Next time you're standing at a gas station, take a close look at the pump. Right next to the octane numbers, you'll usually see those little stickers labeled E10 or E15. We push those buttons every day without thinking twice about what that E actually stands for. That E stands for ethanol, and scientifically speaking, ethanol is simply alcohol. That means when you select that button, you are quite literally pouring high-proof moonshine right into your car's gas tank. Traditional petrol is pulled from a finite supply of crude oil. It's expensive to import, and as this image of heavy traffic shows, it blankets our cities in a thick layer of toxic gray smog. We all know electric vehicles are stepping up to solve this long-term, but fully replacing the world's fleet with batteries requires building new infrastructure from scratch, and that takes decades. We need a way to cut emissions from the millions of combustion engines that are already driving around our cities this afternoon. We need a right-now solution. By replacing a fraction of that dirty petrol with something cleaner, we can immediately stretch our existing fuel supply and start cleaning the air using the cars we already own. To find that alternative, we have to skip the oil rig and head out to a farm. The process starts here, in fields of sugar-heavy crops like this harvested sugarcane. The fuel that goes into your tank begins its life absorbing sunlight and carbon dioxide from the atmosphere. From there, it's essentially a giant home brewing operation. The harvested crop is crushed into a sweet mash, then microscopic yeast is added to the mix. The yeast eats the natural sugars in the plant, and as it digests them, it releases glowing molecules of ethanol. This is the exact same biological chemistry used to ferment beer or distill vodka. The only difference is the hardware. Instead of a small brewery vat, these sprawling, towering distillation columns process millions of gallons of mash to strip out water and concentrate the alcohol. By the end of this massive agricultural and biological pipeline, you are left with pure, highly combustible alcohol. It's stable, it burns hot, and it is ready to power a machine. But you don't usually run a standard car on pure alcohol. You blend it. Think of it like mixing tea and milk. If standard petrol is your dark, heavy tea, ethanol is the splash of clear milk you add to change the chemistry of the entire cup. Look at this beaker combining the two into one uniform liquid. This brings us back to those pump stickers. These E numbers are simple recipes. E10 means the tank is filled with 10% agricultural ethanol, and the remaining 90% is traditional fossil fuel petrol. Now watch the volume shift. Many countries are aggressively targeting E20. Moving the recipe to a 20% ethanol and 80% petrol mix is the new international sweet spot. It provides massive environmental benefits, but is still dilute enough that standard car engines can handle it without special modifications. Then you have the extreme end of the scale, E85. At this level, the dark petrol is reduced to a tiny 15% sliver. The liquid is overwhelmingly pure alcohol, using just that tiny splash of traditional gas to help the engine spark and ignite in cold weather. These E numbers act as a physical slider. It moves the needle away from imported fossil fuels and toward homegrown agricultural crops. Look at how this slider scales up in a country like India. As a rapidly growing nation, India has historically had to ship billions of dollars overseas every single year to buy the foreign oil required to keep its massive cities moving. By pushing their fuel standard to E20, the math shifts aggressively. They instantly substitute 20% of that foreign oil requirement with domestic ethanol. That singular policy change traps billions of dollars inside the national economy that would have otherwise leaked out. The ripple effects hit every level of society. Instead of paying overseas oil conglomerates, that money is redirected into the pockets of local sugarcane farmers. Meanwhile, the cities get a breather, because burning that 20% alcohol blend drastically cuts down the toxic tailpipe emissions clogging urban streets. By blending ethanol, developing economies keep their cash at home, support their own farmers, and breathe cleaner air. But you can't just dump maximum-level alcohol into any car on the road. If you look at these pristine modern engines, their internal fuel lines use standard rubber seals. Alcohol is highly corrosive. Run E80 through this standard hardware, and the ethanol will literally eat away the rubber and destroy the engine. To safely run those high-level blends, you need specialized hardware. That's why you see badges like this one. Flex fuel vehicles are built from the factory with specialized, corrosion-resistant fuel lines and sensors that can analyze and combust anything from E10 all the way up to E85 on the fly. Beyond the engineering, there is a complex ethical tension built into the biofuel model. the food versus fuel dilemma. It comes down to land use. We only have a finite amount of arable soil. If we dedicate millions of acres of farmland exclusively to growing crops to feed our cars, we reduce the amount of land available for food, which can drive up the cost of groceries. Despite the need for specialized engine parts and the careful balancing act of global agriculture, ethanol remains essential. We have hundreds of millions of traditional combustion cars on the road right now, and they aren't going to vanish overnight. Until the entire grid can transition away from combustion, this biological trick of fermenting crops is our most practical, immediate tool. It gives us a cheaper, greener drive today, simply by tapping into the chemistry of alcohol.